This is a trigonometry review part 3. We're going to look at a right triangle here. Suppose we have the angle theta, and the side adjacent to angle theta is x, the side opposite to angle theta is y, and the hypotenuse is r. Number 1, sine theta is y over r. So you notice we're looking at the 6 trigonometric functions in terms of that right triangle. Number 2, cosine theta is x over r. Number 3, tangent theta is equal to y over x. Number 4, cosecant theta is r over y. Number 5, secant theta is r over x. And number 6, cotangent theta is x over y. Now, what we're going to do is we're going to look at an equilateral triangle. In an equilateral triangle, all 3 sides are the same, and the 3 corresponding angles must also be the same. Now, this angle is 60 degrees. And I'm going to drop a perpendicular down. Okay? And we're going to let this be h. Okay? And when you drop a perpendicular down, I'm dropping it down so that this angle is a right angle. Now, suppose the length of this side is 2. Now, we can show that the length down below from here to here is 1. It's half the length of the entire side. Now, from the Pythagorean theorem, and let me write that a little better. So from the Pythagorean theorem, we have h squared plus 1 squared equals 2 squared. But that says h squared plus 1 equals 4. So h squared equals 3, and so h is equal to square root of 3. And so what I want to do is I want to draw half of that triangle. And so this is what we have. So here's my triangle. This is length 2. This is 1. This is square root of 3. And this angle is 60 degrees. This angle up here has to be 30 degrees. And that's a right angle. Why? Because the sums of the angles of any triangle is 180 degrees. And I want you to notice what we have. Number 1, if I look at sine 60 degrees, that's going to be the opposite side divided by the hypotenuse. The hypotenuse is 2. So we get square root of 3 over 2. So this one triangle gives us a lot of information. Number 2, let's take a look at cosine of 60 degrees. Cosine of 60 degrees is the adjacent side 1 divided by the hypotenuse. So this is 1/2. Number 3, tangent 60 degrees. Now, here, there's a couple ways to think about it. You could do sine of 60 degrees over cosine of 60 degrees, or you could look directly at the triangle and you can take the opposite side divided by the adjacent side. So it would be square root of 3 over 1. But square root of 3 over 1 is just square root of 3. Number 4. Now what we're going to do is we're going to look at sine of 30 degrees. Now, actually, before we look at that, let's finish out number 4, cosecant of 60 degrees. I'm just going to take the reciprocal of square root of 3 over 2, which is 2 over square root of 3, Number 5, secant of 60 degrees is 2 over 1, which is 2. And number 6, cotangent of 60 degrees, I just take the reciprocal of square root of 3 over 1, which is 1 over square root of 3. So the triangle gives you a lot of information, okay? And this is just an example of what that gives you just for 60 degrees. And now I want to take a look at 30 degrees. Now, sine of 30 degrees is the opposite side to angle 30, which is 1. So I'm going to take the opposite side to angle 30, which is 1, divided by the hypotenuse, which is 2. So this is equal to 1/2. Number 2, suppose I did cosine of 30 degrees. Now, the adjacent side to 30 degrees is square root of 3. The hypotenuse is 2. Once I have these two, I could get all of them, right? Now, tangent of 30 degrees, well, the opposite side to angle 30 is 1, and the adjacent side to angle 30 is square root of 3. So you get 1 over square root of 3. And then number 4, if we did cosecant of 30 degrees, that's 2 over 1, which is 2. And then number 5, secant of 30 degrees is 2 divided by square root of 3. So I'm just taking the reciprocal of square root of 3 over 2. And your instructor might want you to rationalize, so you want to be aware. And so that's how you would rationalize. And you get 2 square root of 3 divided by 3. And then number 6, cotangent of 30 degrees. That's going to be square root of 3 divided by 1, which is the square root of 3. Now, I want to go over another triangle with you, and that's the 45, 45, 90 triangle. Okay, so in this triangle, suppose this side is length 1 and this side is length 1. This side's 45 degrees, and this side's, that angle's 45 degrees, and this angle's 45 degrees. And we're going to call this side H. And remember that h squared is 1 squared plus 1 squared, Pythagorean theorem. So h squared equals 2. And so h is the square root of 2. So this is the square root of 2. And I want to go through the 6 trigonometric functions here. Now, sine of 45 degrees. So this is the other major triangle. So we're going to take the opposite side to angle 45, which is 1, and we're going to divide by the square root of 2. And so once again, your instructor might prefer you to rationalize the denominator. And when you do that, you get square root of 2 divided by 2. Now, cosine of 45 degrees is the adjacent side to angle 45, which is 1, divided by the hypotenuse, which is square root of 2. And again, it turns out to be the same as sine of 45 degrees. So you get square root of 2 over 2. Tangent of 45 degrees. From that triangle, it looks like the tangent of 45 degrees is 1. Cosecant of 45 degrees, we're going to take the reciprocal of 1 over square root of 2. So that's going to be square root of 2 over 1, which is square root of 2. And then secant of 45 degrees is going to be also square root of 2 over 1, which is square root of 2. So if you notice, I'm taking, here, let me write this as well. I'm taking the reciprocal of 1 over square root of 2. And then cotangent of 45 degrees, well, that's also 1. Okay, so I'm leading to something shortly, okay? Now, I want you to take a look at the unit circle. So we have two triangles, and then we have the unit circle. And remember, that's a circle of radius 1. Now, this point here is 1, 0. And that's going to correspond to this angle here, which, if you want, you could think of that as t equals 0. So the number 1 is cosine of 0 degrees. 0 is sine of 0 degrees. And when you're up here, that's 90 degrees. That's the ordered pair 0, 1. And so at 0, you're at cosine of 90 degrees. And the 1 corresponds to sine of 90 degrees. Remember, cosine is x, sine is y, is how I remember this. Now, we're in business. So I'm going to make a table for you. Here's theta. Here's sine theta. And here's cosine theta. And we have some special angles that we absolutely have to know. Now, for 0 degrees, sine of 0 degrees is 0. So I'm doing it in degrees first. We could do it in radians in another video if need be. Cosine of 0 degrees is 1. Remember that tangent theta, and we made a video about this. This is sine theta divided by cosine theta. And so that's going to be 0 over 1, which is 0. Now, for 30 degrees, sine of 30 degrees, and if you remember, we look back at this triangle here. Sine of 30 is opposite over hypotenuse. So I'm literally referring to this triangle for 30 degrees and 60 degrees. So sine of 30 degrees is a half. Cosine of 30 degrees is square root of 3 over 2. And these are the main two, because if you want tangent of theta, or in this case tangent of 30 degrees, I could just look at the sine and cosine. And so this would be 1/2 divided by square root of 3 over 2. And so this is 1 over square root of 3 because the 2's are going to cancel. So that's what I would do. Now for 45 degrees, you get 1 over square root of 2 for sine of 45. And so again, I'm going to refer to this triangle here. And then cosine of 45 degrees is 1 over square root of 2. And then tangent of 45 degrees is 1 over square root of 2 divided by 1 over square root of 2, which is 1. We got two more main angles. Now, for 60 degrees, sine of 60 degrees is square root of 3 over 2. Cosine of 60 degrees is a half. And that's not a coincidence, by the way. So I don't know if you guys notice. Notice how they switch positions from here to here. And then tangent of 60 degrees is square root of 3 over 2 divided by a half. The 2's cancel, and we get square root of 3. Now, sine of 90 degrees, that's 1. Cosine of 90 degrees, that's 0. So notice from here to here, they switch. And then tangent of 90 degrees is undefined. And so that's the table of special angles that I wanted to introduce to you. What's nice about that? Suppose I wanted to find cosine of, we'll say 135 degrees. And what's nice about this is the reference angle idea. Here's x, here's y. Now, 135 degrees is in quadrant 2. That's here. Now, this angle here is my reference angle. So essentially, it's the angle that you have to add to 135 to get 180 in this instance, right? And so this angle here is 45 degrees. And we know that cosine is negative in quadrant 2. And so I could write this as negative cosine of 45 degrees, and then I go, oh, I know what cosine of 45 degrees is. That's 1 over square root of 2. We just have to attach the negative. And so we get negative 1 over square root of 2. And so if I said defined sine of, doesn't matter. I mean, I could do, well, I'll do 330 degrees. Well, that's over here. And the reference angle, so if I go all the way around, that's 330. The reference angle is 30 degrees because that's what I needed to add to 330 to get me back, to get me all the way around the circle. And so sine is negative in quadrant 4. So this is negative sine of 30 degrees. And I'm like, oh, I know what sine of 30 degrees is. That's a half. And so the answer here will be negative a half. So it's really convenient if you know from 0 to 90. And once you know from 0 to 90, as long as the reference angle is one of those special angles, you're in business, if that makes sense. Now, I want to introduce one more thing to you all. Okay, we know we're going to derive something. Sine of a plus b is sine a cosine b plus sine of b cosine of a. Sine of a minus b. We derived this in another video, and this is sine of a cosine of b minus sine of b cosine of a. And what I want to do is I want to add these equations up. They are equations. They're a special type of equation called an identity, but they're still equations. So I'm going to get sine of a plus b plus sine of a minus b when I add them, when I add the left side. When I add the right side, notice how these terms cancel, and we get 2 sine of a cosine of b. Now, what I'm going to do is I'm going to divide both sides by 2. And so what that says is sine of a cosine of b is 1/2 of sine of a plus b plus sine of a minus b. This is a really, really neat identity that doesn't get taught in trigonometry that much. But I do think it's a useful identity, especially when you get into calculus and there are things that we need to do. So this is called a product to sum formula. So this is product to sum. Okay. We're going to do one more. So suppose I said cosine of a plus b is cosine a cosine b minus sine a sine b. And then cosine of A minus B is cosine A cosine B plus sine A sine B. And we're going to do two different things this time. First one is I'm going to add up both sides. And so I'm going to get cosine of A plus B plus cosine of A minus B. These sine terms cancel, and we get 2 cosine A cosine B. And so if I divide both sides by 2, I get cosine A cosine B is 1/2 of cosine of A plus B plus cosine of A minus B. Okay? That's the first one. Now all I want to do is, this is another product to sum formula, by the way. Okay? And again, it's very useful. Now, suppose I had cosine of A minus B is cosine A cosine B plus sine A sine B. Okay? And then I had cosine of A plus B is cosine A cosine B minus sine A sine B. And this time what I want to do is I want to subtract them. And so when I subtract them, I get cosine of A minus B minus cosine of A plus B on the left side. And on the right side, so notice how the cosines cancel, and I get 2 sine A sine B. But if I divide both sides by 2, I'm done. I get sine A sine B is 1/2 of cosine of A minus B minus cosine of A plus B. And so what I wanted to do is introduce you to 3 product to sum formulas, but I want to give you a sense of where they come from. And they are useful. And so in another video, we can work some more examples of these. And so this will conclude this video for Trigonometry Review Part 3. Okay, thank you.